This is Ascent Tutor, the channel that allows you to master the various concepts in mathematics. You can subscribe to our channel and also click on the ring button so that anytime we place a new video, especially on mathematics, you will get to see it first. Let's get to the classroom.
One aspect of differentiation that proves quite challenging is when we have parametric representation of equations. Normally, our equations are given y equals maybe 2x squared plus 4x plus 6, and we will need to differentiate. But with this particular one, they have given us they have expressed x in terms of t, and they have expressed y in terms of t, and they are asking us to find dy dx in terms of t. So with this, we have to use this method. We will use the chain rule, but it will be a modified version of it. So for the first step, what we'll do is to find our dx dt, and dx dt will give us 3t squared plus 2t, and then we said y equals t squared plus t, so we find y also. We find dy dt. Dy dt will be equal to 2t plus 1. So we have dy dt, and we also have dx dt. But the chain rule says if we want dy dx, it should be equal to dy dt times dt dx, so that the t here, dt here, dt here will cancel, leaving us a final answer of what dy over dx. We just want this and this to cancel. And looking at it very well, we have dy dt, which is this. But instead of having dt dx, we rather have dx dt. And whenever we have dx dt, it means we have turned the answer we need over here upside down. So to put this into this, we need to put the inverse of this, because the inverse of dx dt is actually dt dx, and over here we need dt dx. So this gives us dy dt times 1 over dx dt, because 1 over dx dt will actually give us dt dx. Because if we have let's say dx dt, 1 over that is the same as 1 divided by dx dt, which is 1 times, then we turn this upside down, dt dx. In the end, the whole thing will become dt dx. So it's actually correct. So going forward, this becomes dy dt times dt dx. So actually the inverse of our dx dt will give us what we want. So in the end, we have our dy dt, which is 2t plus 1 times our dt dx, which is the inverse of this. So that will be 1 over 3t squared plus 2t. In the end, we have 2t plus 1 all over 3t squared plus 2t. So that is parametric representation of functions. We had our x equals t cubed plus t squared, and we found our dx dt as 3t squared plus 2t. We have y as t squared plus t, so we found dy dx, that was 2t plus 1. We know from chain rule dy dx is equal to dy dt times dt dx. but we realize what we have here and what we have here are different. The relationship between them is that they are inverse of each other. So if we want dt dx, we can just put the inverse of dx dt there, and that gives us what we want. So our dy dx times dt dx becomes our dy dt, which was 2t plus 1, times 1 over our dx dt, which was 3t squared plus 2t. In the end, we get this. Okay, so if we have a question such as this one, still on the parameters, given y equals a cubed plus 4a and x equals 2a squared plus 5a, and we are asked to find dy dx. The first thing to do is to find dy dA. Dy dA will give us 3a squared plus 4, and then dx dA will give us 4a plus 5. So our dy dx from chain rule should be dy dA times dA dx, so that this and this will cancel to give us our dy dx, dy over dx. But you realize what we have here is not dA dx, rather dx dA. So it's the inverse of this. It's the inverse of this. So instead of writing 4a plus 5, we can rather put the inverse over there, and that will give us our dx dA over dx. So our dy dx will be equal to dy dA, which is 3a squared plus 4, and then dA dx, which is the inverse of that, so 1 over 4a plus 5. In the end, when they multiply, we get 3a squared plus 4 all over 4a plus